3.3b, combining like terms. If we have an equation with multiple variable expressions, combine all like terms first. Then use the principles to solve the equation. So let's jump right into examples. We have to combine all like terms on one side before we do anything else. So example 1, if we look at the left side here, it has two like terms, 3x and negative 3x. Well, why don't we combine them? So 3x minus 3x is 0x, right? So we can just effectively cancel these. This is a nice case of this happening. 7 we don't do anything to, and we didn't do anything to the right-hand side, so we just bring it down. Now we can just use the principles of before to solve the rest of the equation. So first we use subtraction principle. We subtract 4 from both sides to get this 2x term by itself. We end up with 3 equals 2x. And now we divide both sides by 2. Divide by 2, divide by 2. This effectively cancels the 2 in front of the x so that x is by itself, and we bring 3/2 down. This is an example of ending up with a fraction as an answer. It's totally okay. And if we check, it will be an actual solution to the equation. So let's plug it back into the original expression. 3x plus 7 minus 3x equals 2x plus 4. Let's plug in 3 over 2. So 3 times 3 over 2 plus 7 minus 3 times 3 over 2 equals 2 times 3 over 2 plus 4. Well, even before we multiply, these are still positive and negative. They're opposites of each other, so these still cancel out. So we're left with a 7 on this side equals 2, multiplying by 2 and dividing by 2 cancel. So this is a 3 plus 4. And 7 does equal 7. This is a true statement. So our answer of 3 over 2 equals x is correct. So let's solve another equation with like terms, this time with some fractions as well. So on the right-hand side, we notice that there are some like terms, 3 over 2x and x over 2, that we need to combine. So we add them together, and we note our rules of fraction addition. We keep the same denominator, but add the numerators. X plus 3x is 4x, and we keep the denominator of 2. We did nothing to the 4, and we did nothing to the right-hand side. So now we can simplify this right-hand side by adding x over 2 to both sides. Again, we want to get all of the variables on one side so that we can get it by itself. So let's add x over 2 to both sides. By doing this, negative x over 2 and x over 2 cancel, and we abide by the same rules of fraction addition on the left-hand side. So they both have a denominator of 2, which is fine. So we add the numerators together, so we get 5x over 2 plus 4 equals 7. Now we want to get the x term by itself, so we subtract 4 from both sides. And the 4's cancel. We get 5x over 2 equals 3, because 7 minus 4 is 3. Now here's the tricky part, and we can go about this in multiple ways. What I like to do is to multiply by 2 first on both sides. This effectively kills the fraction. So 2 times 2, or dividing by 2 and multiplying by 2 cancel, and 3 times 2 is 6. So we end up with 5x equals 6. Now we can employ the division principle and divide both sides by 5. The 5's cancel on the left-hand side, and x ends up equaling 6 over 5. Again, we end up with a fraction answer, but this is okay.